welcome back. So what you guys are looking at today is 3.1 Scott March Madness. So let's go ahead and jump right in. So for this first part here, we're completing the inequality statements. For each problem, place the appropriate inequality symbol between the two expressions to make the statement true. So if A is greater than B, then 3 times A is what to 3 times B. So if we're multiplying both sides by 3, is the inequality going to change at all? No. So we'll still have greater than. Here we're taking B minus A and then A minus B. So if A is greater than B, when we take A minus B, assuming we have, positive values depending on how far apart they are, we're going to end up with a positive number here. But if A is bigger than B and we're taking B minus A, most likely we're going to end up with a negative number here. So the inequality will be less than. Now in the last one, we're taking A plus X and B plus X, so assuming X is the same in both of them, the inequality is going to hold true because we're adding the same amount to both sides. Okay, that looks really, really confusing. Sorry, this crazy extra lines it likes to throw in. So that's a less than. That's less than. That's greater than. Okay. Let's see. If we look at this one over here where we're saying that X is some number between 0 and 1, which means it's some fraction. If we take and have X in comparison to X squared, so let's say our X value is 1/2, to give some context to this. So if it's 1/2, and then we square 1/2, that's going to give us 1/4. Is 1/2 bigger or less than 1/4? Well, it's bigger than. If we take the square root of X and then have regular X, what's going to happen? It's also going to be bigger because we're going to have to rationalize it, because we'd have the square root of 1/2, which would give us the square root of 1 over the square root of 2. Then we'd have to multiply top and bottom by the square root of 2. So we'd end up with the square root of 2 over 2. So as a result, that's going to be bigger than the 1/2. And then the last one, if we have just X, and if we have 3 times X, our 1/2 is going to be smaller. So on this middle one here, it's telling you that X is greater than 10, so it's any number bigger than 10, and you're looking at squaring it, cubing it, taking the square root of it. So looking through those comparisons there. And you can do exactly like I did and pick some number to use to plug into it to see, okay, if I use this number for X, what's going to happen? That it's always helpful. All right, for the next section, we're identifying the type of function for each problem. So we've got exponential, we've got linear, we've got quadratic, we've got cubic. So we have all these different kinds of functions that we could have. So if we look at this first one here, we're going from 3 to 6, 6 to 12, 12 to 24, 24 to 48. What are we going up by each time? Well, we aren't adding the same thing each time, because between the first two, we'd be adding 3, the next we'd be adding 6. So what do we notice? We're multiplying instead. So 3 times what gives us 6? 2. 6 times 2 gives us 12. 12 times 2 gives us 24. 24 times 2 gives us 48. So that means this is exponential times 2. All right, the next one we're going to look at number 12. So we're going from 3 to 9, which is 6. 9 to 18, which is 9. 18 to 30, which is 12. 30 to 45, which is 15. Are these all the same? Nope. So let's look at the second differences. So 9 to 3, or not, words, sorry. So 6 to 9 is 3, 9 to 12 is 3, 12 to, that should be 15, I wrote the wrong thing. 12 to 15 is also 3. So these are 3 each time in our second differences, which means it's quadratic. I'm just going to put quad. So remember, when your second differences are the same, that means it's quadratic. If our first differences would have been the same, that would mean it's linear. And if our third differences are the same, then it's cubic. So let's go ahead and take a look at 14. So we have negative 26 to negative 19, which is 7. Okay, I don't know where that line came from. Which is 7. And then from negative 19 to 0, that's 19. From 0 to 37 is 37. And from 37 to 98 is 61. So are our first differences the same? No, definitely not. So let's look at our second differences. So from 7 to 19, it's 12. From 19 to 37, it's 18. And from 37 to 61, it's 24. I apologize for the crazy lines. So are our second differences the same? No, they aren't, which means, is it quadratic? Nope. So now we look at the third differences. So 12 to 18 is 6. 18 to 24 is also 6. So this is cubic because the third differences were the same. Okay? So those are the different functions we have. Remember, we also have linear. That's when the first differences are all the same. So keep that in mind. For 16, which of the problems above are not polynomials? So that means it's not linear, or that means it's not quadratic. So all the ones that aren't quadratic are going to be listed here. So we know 10 and 14 aren't. And I will tell you there's one more. So that means all but one of the ones that's left are quadratic. Nice little hint there. All right, the last section, division. So find the quotient without using a calculator. If you have a remainder, write the remainder as a whole number. So example, 149 divided by 21 is 7, remainder 2. So we're going to look at 17 here. So we've got a few problems here. So all of these are looking at long division and then explaining, basically. So can 30 go into 5? No. Can 30 go into 51? Yes. 1 time, so we put 1 up there. We put 30 down here. We subtract. So 51 minus 30 is going to give us 21. We bring down the 0, remember. Now, how many times can 30 go into 210? Well, think about it instead. How many times can 3 go into 21? 7 times. So we put our 7 up there. So 210, subtract, we get 0. So is 30 a factor of 510? Yes. 30 times 17 equals 510. So for any of the ones you get that do not have a remainder, it will be yes, because multiplying the two numbers, your quotient and your divisor together, gets you your dividend. Remember, dividend is the number underneath the division bar. Divisor is the one that you're dividing by, so it's on the outside, and quotient is the answer to a division problem. Okay, so let's do a few more of these. 18, we have 8,359 divided by 13. Can 13 go into 83? Yes, it can. It can go in 6 times. So 13 times 6 is 78. So put a 6 there. This is 78. So 83 minus 78 will give us 5. Bring down our 5. How many times can 13 go into 55? It can go in 4 times, which is 52. Subtract 55 minus 52 is 3. Bring down the 9. How many times can 13 go into 39? 3 times. And we get 0. So this is another one that gives us a whole number. So for 20, is 13 a factor of 8,359? Yes. 13 times 643 equals 8,359. So it works out. All right, the next one we're going to look at, number 21. Can 22 go into 14? No. Can 22 go into 148? Yes. It could go in 6 times. So 22 times 6 is 132. Put our 6 up there. 132. Subtract those. So 148 minus 132 is going to give us 16. Bring down our 5. How many times can 22 go into 165? That'd be 7 times. Oops, sorry. 7 times. We'll just have to deal with the line. So 22 times 7 is 154. Oh my goodness. I apologize for these crazy lines everywhere. 165 minus 154 is 11. Bring down our 7. How many times can 22 go into 117? That'd be 5 times. 22 times 5 is 110. When we subtract, we end up with 7. So our answer is 675. Remainder 7. So for 23, is 22 a factor of 14,587? How do you know? No, it's not. There was a remainder. So anytime there's a remainder, the answer to the question just below it will be no. So you're doing a lot of long division on this. Your keyword is division. Division. So you guys have a few more problems left to do in the long division. Hopefully it won't be too bad for you. If you guys have any questions, feel free to ask. Otherwise, have a great day, guys.